Welcome to yet another session on numeric literals. Okay, now let us deep dive into the numeric literals or numeric category objects. So you might have already known that what is literal. Literal is an expression to generate an object. That's it. Now we will see some of the numeric literals that generates an numeric type of objects and their interpretation. That's it. That should be your expectation for this session, and then we will add one by one on top of it. So now, so the first one is the famous one is our int or integer with unlimited size. The expression is very simple. Use a simple numbers. That's it. You can see it clearly. 1 2 3 4 minus 24 0 999. Don't add anything. You just simply use it like that. What you get is an int. And for float, you must add decimal point. And we also have other ways to write these floating point numbers, but for now that is 4E210 3.14E dash 110. So these are the other ways. And the next thing that now we will look into the topic which is most neglected but most useful in programming universe, that is the number system. So before I start speaking about the number system, what is a number system? So it is a created and a mutually agreed system to write a number of numerals together, which makes a mathematical sense for bigger calculations, is known as a number system. Based on base value and the number of allowed digits, number systems are of many types. The four common types of number systems are decimal, binary, octal, hexadecimal. Let's begin with the decimal. Decimal number system is a number system with a base value of 10 is termed as a decimal number system. It uses 10 digits that starts from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 for the creation of numbers. Example 143123. And second one is binary. Binary is a number system with base value 2 and it uses only two digits, 0 and 1, for the creation of numbers. Some examples of binary number system are 1 0 1 0 0 1 1 1 0 0 1. These are the some examples. And the third is octal. Octal is a number system with the base value 8. It uses 8 digits. That's it, 8 digits. That is from 0, 1, 2, 3, 4, 5, 6, 7. That's it. For the creation of octal numbers, example are 1, 2, 5, 1, 7, 6. It will repeat. Then the fourth one and most widely used in computers is hexadecimal. Hexadecimal is a number system with the base value 16. Hexa 16. It uses 16 digits for the creation of its numbers. Digits from 0 to 9 are taken. Digits from 0 to 9 are taken from the decimal number system, but the digits from 0 to 15 are represented as F, A to F. That's A, B, C, D, E, F from alphabets. So that's the added benefit. So example 185. 185 is a decimal in decimal system, that is equal to B9 in hexadecimal, because see 18, so till 16 till 9 we will use decimal numbers, whereas if you want to write 10 in hexadecimal, you will write it as A. So such a way we will write that. And then 4265 in the decimal system can be written as 10 capital A, 9 in hexadecimal. So these are the different number systems. You have to focus on that, focus on these also. Why? Because so we will use this in Python also. For example, hexadecimal is the one from where we can understand the location of your objects or variable storage. So that's the reason. So for the octal, to use these number systems in Python, we use 0 literal, 0 literal for octal, and 0x for hexadecimal, and 0b for binary. When you mention 0 and some numbers, digits, so automatically the system understands this is octal number system. Okay, fine. So now, then what we have is our complex numbers. This is also very widely used in data science. So the complex number literals we already discussed. It consists of real and imaginary parts. Each part itself is again a float object. That's what the point you have to note. Each part, imaginary or real part, again itself is a float. And the next thing is booleans. Booleans. So booleans are also comes under the numeric literals. Why? Because inherently they are 0 and 1 only. That's the reason these are also comes under numeric literals. And finally, sets. Sets by and large we use it for mathematical operations. So that's the reason they categorized under numeric literals. So now we'll just see some of the built-in calls. So here the built-in calls hex. When you use hex built-in function and you give some integers, it will convert that integer into hexadecimal object, hex object. Similarly for bin, we will actually code it and we will look into it. So convert it. This converts an integer to its representation string in these three bases. Okay, or another way to do the same conversion using int string comma base, which converts a runtime string to an integer per a given base. If you give a base of 8, it's octa, base of 16, it's hex, it's base of 2, it's a decimal. So these are some of the ways of conversion of object from one to one, from one to another. Okay, so in addition to that, Python provides a set of tools for processing number of objects. We'll just look into here. Expression operators and then built-in mathematical functions such as power, amps, round, int, x, bin, and utility modules. Modules we have discussed earlier. We have created a module that's named as module 1. Similarly, they have written a file random.py and they have written some functions in it. When you import a random, and you can actually access the functions in it, it's called a namespace. So we will look into these topics one by one, but for now we will code. So we will start with the part 2, that's a numeric literals. Whatever we have seen thus far, that we will discuss. So here Uh, we'll begin with, as usual, integers in numeric literals. So basically, it is of unlimited size. For example, let's take an example. Let's discuss an example. So, India population. It's a huge number. Simply, we'll say 1.34 billions. But if you actually put it into a decimal system, it is this 134247597. So when I call it India population, what I got is this much, 100 crores, 134 crores. That's 1.34 billion. 1.34 billion, and so that's how that's an example for the integer. So that's how we use it. So here simply just gave this expression. What you get is this int object. Similarly, we will look into the floating point numbers. For floating point number, we will take one example. That's sun equatorial radius in kilometer. That is 695700.56 kilometers, and equatorial circumference also in kilometer, that's suns. It is 43,79,000.35. So these are the some of the use cases for the floating point numbers. I'm just giving some of the use cases so that you actually can understand how do we use these fundamental or core data types in a different scenarios. So when I call it sun equatorial radius in kilometer, so what I got is a floating point number. So on top for population, so basically population is a categorical variable. Means you will it's a so we have a continuous variable, and then so another way. So for continuous variable we have we can use it as a floating point number. For the other variable you can use a category 1 2 3 4 like that only. So that's the reason. So these are the different use cases for it. So now the second thing, we have discussed number systems in our theoretical class. So we will discuss different number systems. We will begin with the binary. In binary, for binary, the code I have written, the reference variable is name is code, and when I say 0 B101, basically it is 10. It is 10 in our decimals. I'll just check it. We'll just cross check it. I just convert binary. See, our code is 10 na. So because I used a binary system, and what I got is 10. So bin of binary, I'm just converting. I just shown converters. So here I used binary, and then the code, the value of code is 10 here. So when I use that, I got the same result. So that's what I just converted. I have written a binary system, binary number system. Then I just converted a decimal number system into a binary number system, and we got the same result. And the second number system is octal. Again, for octal, we'll take it as a number variable, and 0, 12. That's what I have given in an octal number system. Let's see what's the decimal number for this 0, 12. It is 10. It is 10. So when I just convert that 10 using octa inbuilt function, what I got is a decimal number of 0, or decimal number of 0 or 12. So that's how we can actually convert from one number system into another number system. And then the next thing we will look into is hexadecimal. So basically hexadecimal. So the main use case for hexadecimal is our memory location. So that's why for example, we have taken some memory location. The memory location is 0xa. Now you just curious to know what is the location if I convert that into decimal number, because some guys may not understand the hexadecimal system, because we are all used to the decimal number system. So that's the reason we'll just convert that hexadecimal number system into the decimal number system, and we'll see. So memory location 0xa, when I execute this, it is 10 in decimal. Again, if I want to convert, if I just want to convert this back to the decimal, hexadecimal, so hexadecimal, so what I got is 0x comma xa. So that's what this is how we actually interchange or interconvert from one number system to the another number system. Okay, you just follow, you just code it, you just code the same thing with me. Okay, the next thing we'll look into is booleans. So booleans, when I say x is equals to 45 and y is equals to 56, so basically 45 is an object, is stored, will be stored in an object memory space, and x is a variable, or simply call it a name in Python. It's a name, it's just a name, and it will be stored in different memory location. It's a variable memory location. But here what happens in Python, this x will be referenced to the 45. So then that's how the assignment takes place. So now here the meaning of x is equals to 45 is 45 is an object, is an int object which is a reference to the name x. That's it. So x is equals to 45 and y is equals to 56. When I say x double is equals to y, it is also an equal. It's also an expression. It's also an expression, and this equal to is called expression operator, and double equals to is called an equality operator. This is called assignment operator, and this is called equality operator. So when I execute this, it's showing false. So these are actually boolean. And when I say x not is equals to y, same. It's true. So that's how we use boolean expressions to do some tasks. Now the next thing we'll look into is sets. For sets, what we will do is we will take some engineering subjects as an example, math subjects, and then computer science subject, that's CSE subject. There are two sets. Math subjects set, that's maths, physics, chemistry, and machine design elements, and more. And similarly for CSC subject, CPNM, computer architecture, algorithms, maths, physics, chemistry, and more. So now I'm curious to know that what are the common subjects in math and CSE. Let's see. Without looking into the subject, we'll get it. So chemistry, maths, physics are the common subjects. So that's how we this is how we use sets in real life situation. Now built-in calls we have discussed earlier. We can convert a decimal into hexa. You can convert decimal into octa. You can convert decimal into binary. For example, hex 45 is 0x2d, and oct 45 0o55, and bind 45 is 0b101101. This is how we actually convert from decimal to different other numeric number systems, that is hexa, octa, bin, and finally we are entering into some utility modules. These are called inbuilt utility modules. These are written by Python inventors who has written the whole Python application. They have written this. For example, see, similarly I have told you we have written module.py in our previous video. In that we have written a file module1.py, and we can import that. Similarly, they have written random.py, and they put these functions in it. They have written this is called a namespace. The module itself is called the namespace because there are plenty of names in it, and we can use those names to do some functions, some tasks. So that's the reason this is called namespace. So basically this file consists of okay, so the top portion from here, bpf log4, these are uh, these are higher level, or we will discuss later in this in our course, but as of now we will discuss the bottom part. So these are from the one which doesn't have any underscores. These are all our methods or in functions of that module. So these are written in that module file. That's a random.py. When you use import and the file name without extension, you are able to call that file, and you are able to enter into that random file when you type dir random. So you are actually able to access and look into the what all names or functions or methods inside that namespace of random module. Similarly, we can use another module that's called math module. So that math module also another math.py file which is written pre-written. So and this consists of these many methods. From here you can see this from you have plenty of methods. It consists of from here to here. These are plenty of methods we have in this module. These are all functions written in math.py. Cos hs, sin hs, degrees, these are all absolutely mathematical methods. Sin hs, sin h, square root, tan hs. So these are very useful while working with data science projects. So with this we had an in-depth discussion or look into the in-depth look into our numeric literals. So now, so next, so what we will see is now let us have a sneak peek into the expression operators. Okay. So before actually begin expression operators, I just want to tell you that the following table lists all operators from highest precedence to the lowest precedence. When you write an expression out of which uh, the one which I have mentioned in the top of the table will have a highest precedence in execution, and as you go down the table, these are the one which will have a lowest precedence. Okay, so now perhaps the most fundamental tool that processes numbers is the expression, a combination of numbers or other objects and operators that computes a value when executed by Python. Okay. Now, in Python, expressions are written using the usual mathematical operators. So those are, the first mathematical operator is asterisk, double asterisk. So it's called exponentiation or rise to the power, and second one is plus or minus for addition and subtraction. And now let us have a look at the following table, which actually lists all operator from highest precedence to the lowest, that I have already told you. Now the second one is the comparison operators. So basically, so I'm explaining all these and I'm repeating the names and types of operators because you should know this terminology so that you actually can talk to your colleague and other person who is a programmer. So without knowing the proper terminology, it is difficult to deal with any error or to understand a specific program. So that's the reason I'm trying to give the specific name for each and every tool that we use in this Python program. So these are all operators, plus, minus. These are called expression operators. We have seen an expression x is equals to 5 is an assignment expression. In this expression, equal to is an operator. So similarly, we have plenty of expressions, different types of expressions, out of which will have a different types of operators, and each operators will do a specific type, specific task. We will actually discuss what task it does in our coding session. So as of now, you just note down the name and type of operator. That's it. So here, these are all comparison. What we see is, so these are all mathematical operations. That's asterisk. So the first one is multiplication. Second one is division. The forward slash and then modulo, and then the third one is the next one is the double forward slash is for the floor division, and the second one, the next one is comparison operators. The comparison operators such as less than and less than are equal to, greater than or equals to, are used for the comparison purpose with some other same type of object. Okay, and next thing is, we all know equality operators such as double equal to and not equal to. Actually, these are used to check whether something is equal to some other object or not. That's it. And the next thing is, the most used operator is assignment operator. Assignment operator such as equal to will connect. So I have already told you this. Equal to will connect a reference variable with an object. An object will be stored in some other location. A reference variable will be stored in some other location. When you give an equal to an assignment operator between these two objects, it actually connects those. So that's what we call it as an assignment expression. So similarly, we will have a compound assignment operators such as plus equal to, minus equal to, and uh, forward slash equal, such as some other assignment operators. You can actually look into it. These are all are used to do referencing as well as arithmetic operations together. So that's why these are called compound assignment operators. Now, the next thing is identity operators such as is not, are used to find out whether two objects are similar or not. And membership operators such as in, not in, are used to identify whether the certain object is a member of a sequence of list of items or not. We have seen what is a list object, what is dictionary object, what is tuple object. These are comes under sequences. We will look into it later in this course. But as of now, you just understand what are membership operators. And then widely used logical operators such as not, or, and will be used very much in writing logics and conditional statements. And the most important operators for IoT is bitwise left and bitwise right, as well as ampersand and vertical line. So basically, I'm working on IoT projects also, Internet of Things projects. While I'm working on these projects, I got to know that these operators are very much while executing or while writing some conditionals. That's the reason I'm putting it. Don't neglect this. Try to learn this also. Okay. So now, so parts of expression with parenthesis, when you enclose in sub expressions in parenthesis, will have a highest precedence. That's what. So it is similar to our mathematics only. When you use parenthesis in your expression as a sub expression, that will have a highest precedence than compared to all of these. And these are the some of the examples that will code it later in this session. You don't need to worry about this. Okay. So now we will code. Again, we'll begin with arithmetic or mathematical operators, then we'll enter slowly into other types of operators. So first, arithmetic operator. You'll just look into the example first. You don't worry about anything. You just look into the example and enjoy the session. That's how you can learn. So population is growing exponentially. Okay. So that's what the example we have taken. So present population, let's take 1.43 billion. Then year is equals to, I'm just giving input. Okay, I want int object only so that I can do the arithmetic or mathematical calculation. So that's the reason. Now I just want to, we know population in India is growing exponentially. So now I just want to take this example and do some use some arithmetic operator to find out the population after some time. So now population, this is a calculation. So population is equals to present population, that's in 2022, times as it is exponential, as it is growing exponentially, I use exponential operator, and this is year. So now I'll give 2024. So here what we have to do is, just a minute. In April 2022 is 1024. These are big vehicles. Take JCBs, and sales in June 22 1000, sales in July 22 it's 989. So now what I want is sales in financial year 23 YTD, year till date. So in that case it is a summation of all that. Here I have used plus expression operator. So the motto here is to understand how expressions are generating an object first, and the second thing is how we are using expression operators or simply an operator to make an expression and to generate an object. These are the two fundamental objectives we have here. So the sales for financial year 23 is, okay, it's taking some time to execute this code, but that's fine. We'll get, by and large, we'll get okay, that's a 3013. Whenever your Jupyter book stuck, you just restart the kernel. Okay. Now, and the third example for the arithmetic operator is percentage of vehicle sales in month of April. Okay. So here what we are using is forward slash, that to calculate percentage. So it's a division. So we got 33 percentage of vehicle sales. Percentage of vehicle sales in total sales of financial year YTD. So here this is whole division. this this one is a whole division. So we have other types of divisions. One is modulo and other one is so we have other type of floor division. So but whereas this one is if you use a single forward slash, this is a whole division, it will do the complete division, and you'll get a floating point number as an object. Okay, and then next example we'll look is forecast for next month vehicle sales. So we will use a percentage as more. So now forecast for August. Of course, we are in August now. Don't worry. So now sales in July 2022, and we are expecting that 5% of increase in our sales. So let's see. So 1038.45. So we cannot take this number because this is a vehicle. So we will round it off either to bottom or up. So now in this case we can actually use so now the second one is we'll use another example we'll look into is modulo gives us a reminder. So if you take 5 and modulo symbol and then 2, what we will get is 1, because 5 divided by 2 we'll get a remainder and 2 as a quotient. Okay, so modulo gives us a reminder, keep in your mind. And for floor division we'll get a quotient. That is, if you do the same, what we got is, so sorry, what here it is, floor division gives us a quotient, because if you do the 5 double forward slash 2 will give you 2, that's a quotient. And division, a whole division or division gives us a floating point number, so that's the 2.5. Okay, till now we have discussed arithmetic operators. Now we will enter into comparison operators. Okay, comparison operators. For comparison operators we will use the same example of the vehicle sales. So which month sales are higher, so sales April 22 and sales June 22, we'll use a greater than or equals to. This is a comparison operator. So yes, sales of April 22 are greater than sales of June 2022. Fantastic. Now we just want to check whether sales of July 22 are greater than sales of June 22. No, not at all. They are lesser than that. Now we will see equality operator. You just code along with me. You just sit comfortably and just follow whatever I am coding here. Okay. And the next thing we will look into is equality operator. So equality operator, we have again, we just want to check whether sales in April 22 is equal to sales in June 22. It's not. And we want to check sales in April 22 are not same as sales in June 22. Let's see whether they are same or not. Yes, they are not same. This is how we use equality operator. So these are the equality operators. And the next thing we will look into is assignment operator. So for assignment operators, thus far we are using assignment operators, but we'll go a little higher level. So batch 2022, we have discussed what does this assignment operator mean also. So here I'm running a course. So in batch 2022, we have 150 members enrolled to it. So let's take an example that 20 new students were joined this year. It's not this year, this month. So now how will you add this 20 number students to the existing batch? So this is how I do batch 2022, and I use a compound assignment operator, that is plus equal to together, then I'll put 20. This makes this is equivalent to batch 2022 is equals to batch 2022 plus 20. Okay, so now when I execute this, it has become 150 plus 20, 170. Okay, this is how we use a compound assignment operators. And the next thing we will look is identity operator. That's fine. Identity operator. So here let's take one example. So in batch 2022 we have student names A, B, C, D, E. In batch 2022 we also have some students with names G, D, A, R, J, S, C. Okay, now I'm curious and excited to know that whether batch 2022, the whole batch 2022 is member of batch 2021. So actually I have used a list literal to generate a list object. From this we can use an identity operator is to find out whether this batch is in that batch or not. I'll see it is not at all. Okay, let's find out in another way whether this whole batch 2022 is not in that batch. Obviously it is not there in that batch. That's the reason we got true object. Now we will enter into the membership operator. So we have discussed in batch 2022 we have different number of names. Let's see, let's check whether name A is in batch 2022 or not. Yes, it is there. And name B, whether it is there in batch 21 or not, it is not there. I said B not in batch 2021. Yes, it is not there. So this is how we use membership operators in and not in our coding. Next, what we will look into is logical operator. So logical operator, it is used to do a little higher tasks. So for example, here you don't worry about the if statements. If statements, you don't worry about the if statements. I'll just you just understand it how a logical operator works. Okay, we will look into the if statements later in this course, but as of now you just understand the flow. If, and this is the name of our student A. In is our membership operator, and batch 2022 is a list object and batch 2021 is in another list object. And I just want to know, I just want to check the condition that whether this guy that A guy is in both batches 2022 and 2021, because if some guys who wants to learn more, they will continue in the second batch also. So that's the reason. If it is there, I just give A is repeating this course again. Okay, let's check. Yes, this guy is in both batches. So that's how we use and logic operator. Similarly, we will see another example. S. There is S guy, the name of the student. We'll check whether this guy is in both batches. If this guy is not in both batches, then print it as this guy is a fresher. Let's check whether this guy is a fresher or senior student. He is an absolute fresher. So this is how we use expression operators in real life. So now let's move on to Python expression operators and precedents. So basically, so thus far we have discussed the theoretical aspect and then coding aspects. Here I just want to give you a complete picture and complete expressions that we have in Python. So you don't need to worry about everything. I'll just read through it. You try to remember and note it down, so that whenever you see these kind of expressions and operators, you are able to recollect the name of it so that you can use with your colleagues. Okay, the following are some of widely used expressions and expression operators. Let us begin with most complicated operator, that's yield, because this yield will be used in functions. So that's the reason I'm just giving a clear picture of everything before you actually enter into the main aspects of our Python programming. Okay, so now for yield, yield is the keyword that works similarly as the return statement does in any program by returning the function's values. But what is the difference between return and then yield? However, the return statement only returns the value from the function, whereas yield statements returns multiple values by returning one value and wait, then it again resumes by saving the local state. Such functions that use yield statements instead of return statements are known as generator functions. In a nutshell, a return gives back a value and values, whereas yield gives a generator function. It only gives a generator function, and you need to use some loop to look into those values in that function. So that is the difference between the yield and the return. We will actually look into this after some time. Okay, and then the one more another important operator is our lambda. A lambda function is a small anonymous function. A lambda function can take any number of arguments but can only have one expression. So we will look into that in functions module. Don't need to worry about that. Okay. Now, so some other expression operators here are X if Y else check. This means it is a ternary selection, and when you say X or Y, it's a logical OR. This means Y is evaluated only if X is false. When I say X and Y is evaluated only if X is true. This is logical AND. And not X means logical negation. X in Y, comma X not in Y means these are membership operators that we have discussed. This is applicable for iterables and sets. And X is Y, comma X is not Y. These are identity operators. This does object identity tests, and we have X less than Y, X less than or equals to Y, X greater than Y, X greater than or equals to Y, X double equals to Y, X not equals to Y. So these are all magnitude comparison, set subset and superset and value equality operators. And when I say X and vertical line Y, so these are bitwise R and set union. These are very much useful when you deal projects in Internet of Things. And I have told you X shift left or right by bits. So that is one more important thing. And we have addition and concatenation. The plus operator used for the addition. If it is numeric objects, if it is a string, it will be used for the concatenation. And minus operator will be used for the subtraction and set difference. And asterisk will be used for the multiplication. If it is int object or if it is a string object, we'll use for the repetition. This is what we call it as Python. Okay, so these are arithmetic operators, and similarly we have module, reminder format, and we have division, true and floor. Second one is a floor, we have discussed, and we have negation, identity, and exponentiation. And the most important things you should note down here is x of I. This is called indexing, and then x of I through k is called slicing, and x of, this is to call a function, call a method, call a class. See, you just remember these operators. Every operator you should know so that you can use it well in future. So when you use a parenthesis, with the name, this is used to call a function or method, class, or other callable item. Anything, it might be anything. And when I say x dot attribute, it's called attribute reference. We have done it in modules. In modules, we have taken a module one, and from that you can call a function. That's what it's called, attribute reference. And if you use a parenthesis, a simple parenthesis, what we get is a tuple. And if you use a square bracket, list and list comprehension, if you use a dictionary, curly braces, we got a dictionary. So with this, we are good to go to the string data type. Thanks, and keep watching, keep subscribing. Let everybody know this Python very well so that we can use it very well. Thanks, and thanks again.